Okay, let's dive into this. Welcome to all the environmental authorities, agricultural drainage specialists, and pollution control analysts tuning into this explainer today. You guys are the ones on the front lines crafting policy that actually has to work in the real world, which is exactly why today's topic is absolutely crucial. We're going to examine a fascinating policy paradox happening right now in California. It's a massive dairy methane program that honestly looks incredible on paper, but hides a profound and frankly alarming environmental trade-off. We're essentially looking at how a well-intentioned subsidy might actually be locking in long-term global warming. So here's how we're going to break this all down today. 1. The seemingly perfect methane policy. 2. The hidden carbon math trap. 3. Methane versus CO2. 4. Cooling versus warming. And 5. Ending paper progress. We are going to systematically deconstruct this policy from top to bottom. All right, Section 1. The seemingly perfect dairy methane policy. Let's see why this might just be a win-win illusion. At first glance, California's massive dairy methane program seems like a total, flawless win-win for both the climate and the agricultural sector. The state has set up this highly popular system where they basically pay dairy farmers generous subsidies to take polluting cow manure and turn it into useful natural gas. So instead of just letting that waste sit there and emit harmful greenhouse gases into the atmosphere, the agricultural sector is directly incentivized to capture it and turn it into a really valuable fuel. Sounds like a brilliant solution, right? But to really understand this, especially for you regulatory professionals out there, we've got to break down the actual mechanics of this complex carbon credit loop. Step 1. On typical dairy farms, manure just sits in these massive open lagoons where microbes break it down, releasing methane. Step 2, farmers use state subsidies to install anaerobic digesters. These are essentially giant, sealed containers that capture the resulting biogas. Step 3, this captured biogas is then converted into natural gas and injected into pipelines to power vehicles or power plants. And Step 4, and this is the absolutely critical part, this process generates what are known as Low Carbon Fuel Standard, or LCFS credits. Because this biogas supposedly prevents massive methane emissions, oil companies can actually buy these credits to offset their own fossil fuel emissions. It basically allows them to meet state climate regulations without actually cutting their own pollution at all. Which brings us to Section 2, the hidden carbon math trap. Let's look at this misleading equation. Now, capturing methane is for sure a good thing. But this popular offset system hides a major structural flaw, built on a totally oversimplified equation. Just look at this number, 26. I really want the sheer disproportion of this trade-off to sink in for a second. This represents the vastly distorted scale of the offset math currently being used by regulators. Now, what's really interesting about this slide is exactly how that math plays out in the real world. According to UC Berkeley economist Aaron Smith, adding just one average biogas-powered vehicle to the fleet generates enough LCFS credits to offset the deficit of 26 similar gasoline vehicles. I mean, just let that sink in. One single biogas vehicle gives an oil company the regulatory permission to keep emitting the carbon equivalent of 26 standard gasoline cars. These credits are incredibly overvalued. It creates a massive loophole. And this right here is the fundamental danger of the carbon offsets. An offset is basically a complex incentive mechanism where responsibility is traded between parties. Instead of demanding direct, hard emission cuts from polluting industries right at the source, lawmakers rely on these super complex systems. And the result? Well, as we see in the dairy subsidy program, these mechanisms often drastically overestimate the actual emission reductions achieved where it actually matters, up in the atmosphere. All right, Section 3, the crucial difference between methane and CO2. We really need to talk about lifespan asymmetry. For those of you managing agricultural drainage and environmental pollution, we have to look past the accounting tricks and confront the hard scientific reality of atmospheric chemistry. Why exactly are methane and CO2 so drastically different? Well, methane is highly potent, yes, but it generally breaks down very quickly within the atmosphere, usually within a few decades. Carbon dioxide, on the other hand, accumulates. The CO2 we emit today, that's going to continue to warm the Earth for hundreds to thousands of years. The fatal flaw in California's math is that it assumes methane is just 25 times more potent than CO2 over a flat 100-year period. It completely ignores this absolutely crucial asymmetry in their lifespans. Let's move to Section 4, short-term cooling, long-term warming, a pretty grave trade-off. And this brilliantly illustrates exactly what's going on. By trading a short-lived gas for a long-lived one, we are essentially guaranteeing short-term cooling but long-term warming. Just look at the exact timeline of this policy failure. Today, anaerobic digesters capture methane, generating valuable offset credits for oil companies. Decades later, say around 2050, that methane, even if it had been released, would have naturally broken down and disappeared from the atmosphere anyway. But millennia later, the CO2 emissions that the oil companies were permitted to release because they bought those credits, those will still remain, actively warming the Earth. We are literally sacrificing long-term climate stability for the fleeting illusion of a short-term fix. So, just to quickly summarize the 3 critical takeaways from our source data here. First, this program's structural defect directly causes long-term CO2 accumulation by allowing fossil fuel emissions to just continue unchecked. Second, ignoring the distinct lifespan asymmetry between methane and CO2 leads to wildly overvalued emission reductions on paper. And third, this exposes the urgent need to shift away from these convoluted offset trading schemes and move strictly toward direct emission regulations. Section 5. Breaking away from paper progress. Why it's time for direct mandates. So, the crucial point is, how do we actually fix this flawed approach? We're living in an era that requires full, aggressive decarbonization across every single sector. We just cannot continue to use a system that rewards one industry for simply choosing not to pollute while selling that good deed to another industry so they can keep right on polluting. It's basically an accounting shell game. We've got to abandon the idea that we can pay sectors for the favor of not polluting our air and instead implement direct mandates. I want to leave you with this final kind of provocative thought based on the source material. Can society really continue to rely on this illusion of paper progress while pushing massive, irreversible environmental burdens onto future generations? For those of you tasked with protecting our environment and regulating agricultural impacts, the answer is pretty clear. It's time to abandon offset-dependent systems and enact genuine, direct regulations that protect our atmosphere, not just for the next 10 years, but for the next 10,000.